Okay, chemistry, I'm going to do some of the homework problems on the stoichiometry homework number 2. So this would be a very good video to watch. You do not have to do all the homework problems on this homework assignment. So look carefully to see which ones I am assigning. I'm going to start with number 2. We're skipping number 1. We're going to start with number 2. Iron reacts with oxygen to form iron 3 oxide. So the first thing we do is we have to write the equation. Okay, so we've got iron and it's reacting with oxygen. Remember that oxygen, when it's by itself, always has to have a 2 because it's one of those diatomic ones. And it makes iron 3 oxide. So that tells us that the charge on iron is 3. And from the periodic table, we know that the charge on oxygen is 2. So when we do this, iron oxide becomes Fe2O3. So that's the first step in a problem like this. You have to actually write the equation. Now we have to balance the equation. Is it balanced? No, it is not. There are 3 oxygens on this side and 2 on this side. So let's put a 3 here and a 2 there. Now there's 6 oxygens on both sides, but over here there are 4 irons. So we have to put a 4 here. Now it is all balanced. That is the first step always in these problems, is to make sure you are starting with a balanced equation. Now we can go ahead and do the problem. If 10 grams of iron, so write what you're given first, okay? And we want to find out how many grams of iron oxide, which is this, is produced if 10 grams of iron is in the beginning. So we're going to take this and put it on the bottom and change it to moles. Remember that you always change it to moles first. Then we're going to take this and put it on the bottom and put moles of what we're trying to find on the top. Then we're going to take this and put it on the bottom and put on top what we're looking for, which is grams of iron 3 oxide. So that's what we're looking for. So you can see that these cancel, those cancel, those cancel, and we're left with this, which is what we want. Now let's fill in our numbers. Grams and moles, that comes from the periodic table. 1 always goes with the mole. You're going to look on your periodic table and find iron, and you're going to see that it is 55.85. So that goes right there. And then these next numbers come from our balanced equation. Iron has a 4, Fe2O3 has a 2. So that's where those numbers come from. Here again, grams are always from the periodic table. There's always a 1 by the mole. So you're going to look this up on the periodic table and add 2 irons and 3 oxygens together, and you should get 159.70. Now you're going to do this problem on your calculator, and your answer is 14.3 grams of iron 3 oxide. And that is your answer. This is the kind of way I want you to do these problems. I want you to write this out. So even when I get pictures of your homework, I want to see this written out so that I can see that you are using all the steps. When we do a quiz on Friday, it's going to be on formative, but I'm going to have you also attach a picture of your work just so I can see it. All right, so I did all of number 2. Let's look at number 3 for this homework. balance the following equation. So that's the first step. They did not ask you to make the equation here. They're just asking you to balance it. You cannot do these problems if you do not start with a balanced equation. If you are having problems with balancing equations, you need to go online and find some help with that. Maybe Khan Academy or something like that, and look at balancing equations, or contact me and maybe I can Zoom just with you or something so that we can go over balancing equations. Okay, because these problems will not work if your equation is not balanced. So let's see, is this balanced? We got 1 aluminum, 1 aluminum. 3 chlorides, oh, nope, it's not balanced because we've got 3 chlorides over here and only 1 over here, so let's put a 3. But in doing that, that gave us 3 hydrogens here, but we also have 3 hydrogens here, so that gives us 6. So we're going to have to put a 3 here, so we have 6 hydrogens, which gave us 3 oxygens, and we have 3 oxygens over here, and now I think we're all balanced. Okay, now the equation is balanced. I am going to do part A. You are going to do part B for homework. 3B is homework. All right, you're going to write what you are given. We're starting with 50.3 grams of ALOH3. First thing you do is change it to moles. You have to have moles to start with. So we got to change it to moles. Then we're going to put, so look what we did. This goes with that. And then we're going to take this and put it on the bottom so that it cancels. So now that canceled. And we're going to put moles of what we're looking for. What are we looking for in number 3? How many grams of AlC3? AlCl3. That's what we're looking for. But we're looking for grams, so I'm going to have to move down here. We're going to have to put moles of AlCl3 on the bottom and grams on the top. I don't know why I switched colors there. This one's going to cancel with that one, and we're left with this, which is what we're looking for. So let's go ahead and fill in our numbers. This first one right here, we have moles and grams. Moles and grams always come from the periodic table. You're going to look that up. You're going to have 1 aluminum, 3 oxygen, 3 hydrogen, and you should get 78.01. Then these next ones come from your balanced equation. Look up here at your equation. What's the coefficient in front of AlCl3? 1. What's the coefficient in AlOH3? 1. Then down to this next one, it's grams and moles again. Moles always get a 1. The grams come from the periodic table. 1 aluminum, 3 chlorides. You're going to look that up on the periodic table, and it should be 133.33 grams. Do this problem on your calculator, and you should get 86.0 grams of AlCl3. And that's your answer. 3B, I want you to do. Okay, you're going to do 3B for homework. That's your first homework problem on this sheet. Now let's look at number 4. Let's look at number 4. And number 4, you need to balance the equation and then find this. So we're going to balance the equation together, and then you're going to do the problem. C6H6 plus O2 H2O plus CO2. So the first thing we have to do is balance. Let's see, we got 6 calcium on this side, and we got so at only 1, I mean not calcium, carbon, and only 1 on this side. So if we put a 6 there, that has that has our carbons balanced. And we got 6 hydrogens here, so we would have to put a 3 here in order to have our hydrogens balanced. So now this gives us our carbon and our hydrogen balanced, but let's see how many oxygen it gives us. 6 times 2, 12, 13, 14, 15. That gives us 15 oxygen on this side. But look, this is a 2. There's no way we're going to be able to make that into a 15 since it's odd. So we're going to have to do something different. Instead, let's put a 2 here. And in doing that, that gives us 12 carbon. So we'd have to put a 12 here. And it gives us 12 hydrogen. So we'd have to put a 6 here. Now let's see what that gives us. 12 times 2 is 24 plus 6. That gives us 30 oxygen. We can make 2 into 30 by putting a 15 in the front. So that is balanced now, and our coefficients are 2, 15, 6, and 12. And there isn't anything that goes into all those numbers. That's reduced as much as we can. So we know that that's good. So number 4, this is balanced. I want you to do 4A for homework. So now you have 2 problems to do, 3B, 4A. All right, let's look at number 5. Iron reacts with chlorine gas to form iron 3 chloride. Write the balanced equation. Okay, iron and chlorine gas. Remember, chlorine has to have that too. And it makes iron 3. Oh, I was going to put oxygen, but it's chlorine. Chloride. And if you look on here, chloride is a -1. So if we do that, this becomes FeCl3. So there's our equation. And now we got to look to see if it's balanced. Is it balanced? No, it's not. We have 2 chlorine on this side and 3 on this side. So we're going to have to put a 3 here and a 2 here, which gives us 6 chlorine on both sides, but it gives us 2 iron on this side, so we got to put a 2 there. Okay, that's how you balance equations. Looking at the coefficients, 2, 2, 3, 2, that's reduced. There's nothing that can go into all those numbers. So this is the balanced equation for number 5. I want you to finish it. Go ahead and finish number 5. So now you have 3 things to do, 3B, 4A, and finish number 5. Let's look at number 6. Number 6, how many grams of, or complete and balance the equation. All right, so let's look at that. We've got Zn plus HCl. And what do you think let's do your best guess what we could do with this equation. This would be a single replacement. So we're going to replace the zinc with the hydrogen, and then the hydrogen's going to be by itself. So we're going to have hydrogen by itself over here, and hydrogen always has a 2 when it's by itself. So we got to put zinc and chlorine together. Chlorine has a -1, and zinc has a +2. So when you go like this, that becomes ZnCl2. And that is what the equation looks like. Now we got to check to see if it's balanced. Is it balanced? No, it is not. We have 2 chlorine on this side, so we're going to have to put a 2 here. That gives us 2 hydrogen. We already have 2 hydrogen on this side. Now it's all balanced. This is the balanced equation for number 6. I want you to do A and B on number 6. So now you're doing 3B, 4A, you're finishing 5, and you're doing 6A and B. All right, so let's look at number 8. We're going to look at number 8. We've got N2 plus H2, and that gives us NH3. First thing we got to do is balance our equation. Is it balanced? Nope. We got 3 hydrogen and 2 hydrogen, so let's put a 3 there and a 2 there. That gives us 2 nitrogen. We have 2 nitrogen. It's all balanced. So let's go ahead and do 8A. Okay, let's write what you start with. 6.50 moles of H2 at STP. We already have it in moles, so we don't have to change it to moles. So we're just going to put moles on the bottom, and I'm not going to write the STP because it's good. I'm going to run out of space. And we're looking for moles of NH3. So look, we only have to do 1 here. All we're doing, we're taking moles and changing it to moles. So what are we going to put in there? Our coefficients from our balanced equation. H2 has a 3, NH3 has a 2. So that's where those come from. You do this problem on your calculator, and you get 4.33 moles of NH3 at STP. And that is your answer for 8A. I want you to do 8B. 8B. Okay, you're going to have to do one more step because it's asking you no, you're starting with grams. You're not starting with moles. You're starting with grams, so you're going to have to change it to moles and then do a problem like this. That's 8B. That's your next homework. And then your last homework question is question 10. I'm not going to do any of it. I want you to do all of 10 by yourself. You need to balance the equation and then find the answer. Start with what you know. Start with what you're given. 4.0. Oh, this is a hard one. I'm going to help you with this one. Because they don't give you grams, they give you kilograms of iron oxide. So before you can go on, you're going to have to change that to grams. So we're going to put kilograms of iron oxide to grams of iron oxide. And you're going to say 1 kilogram is 1,000 grams. And then you're going to go ahead and say gram. Now we're into grams, so we can change the grams to moles. And then we're going to change the moles of iron oxide to carbon monoxide. Carbon monoxide. That was wrong. That's carbon dioxide. So moles of carbon monoxide, and we're looking for, that's what we're looking for. So we're done at that point. So I helped you more than I was going to on number 10. You need to balance the equation and then fill in the numbers for what I have right here and find the answer for number 10. So your homework for this homework sheet, you're going to do 3B, 4A, finish number 5, 6A, 6B, 8B, and finish 10. Right? 1, 2, 3, 4, 5, 6, 7. 7 problems on this homework paper, and I started some of them for you. So go ahead and do this, and then on Friday, we're going to have a little quiz over this.